So we've been looking at the unit circle using an X and understanding that on a unit circle, we're taking a coordinate grid and just putting a circle around it. Okay, so that's basically all a unit circle is. We still have our X and Y axis, and then finding our coordinate points for 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. So, and you know what, you guys, some of you already put your unit circles away. You might want to keep it out because just look on to somebody's that's handy, because we will be kind of referring back to it just a little bit. This first part, the only thing we're going to do now is we're going to freehand sketch different angles. I am not going to be pulling a protractor out to make sure that, oh, Ashton, you're off by 5 degrees on that. As long as you're close and in the right quadrant, I'm going to call that good, just so that you have an understanding of about where that angle would lie, okay? So this first paragraph is just giving us some definition. It says you can generate any angle by fixing one ray. You guys, a ray has an endpoint, and then it just extends off in one direction. And that ray is called the initial side, and for the most part, that's going to be the x-axis. And then we rotate the other ray, called the terminal side, about the vertex, which is actually the origin. This is a lot of verbiage for something very simple. So draw yourself a nice x and y axis. My y is a little crooked, but that's all right. There's my x-axis, and that is going to be my initial side, because that is where I'm starting to rotate an angle. And I've got a little gimmick here that I'll actually show you what I mean. So let's say we want to draw a 45-degree angle. So we know that 45 is smack dab in the middle. And so what it's saying, what this paragraph above is saying, is that we start at the x-axis, and then we move up, rotate up 45 degrees, and then we stop. Where we stop is called the terminal side. Where we stop is called the terminal side. And we're going to be using a lot of definition as through that. So I really want you to understand that. So here's my little gimmick, and I'm going to first get it so that it's on the video. What's underneath is the red side. The red side is going to be the x-axis, which is the terminal side. I'm going to rotate the blue up about 45 degrees, and that is my terminal side. So for you guys, the x-axis is the red. I'm going to rotate this up about 45 degrees. The initial side, I think I said that wrong, the red is the initial side. The initial side is what stays put. It doesn't move. The terminal side is moving. But where it ends, boom. That's why it's called terminal, because that's the ending. What's created is the angle inside. So every angle is created with an initial side, which is typically the x-axis, and it ends with the terminal side. The angle is created is in the middle, okay? So what we're going to do, giving this information, you see 3 different angles that we have down below here. We have 210, 510, and 315. We're going to just do a rough sketch and tell what quadrant each one of those are in. So the first thing you're going to do is just draw me an x and y axis. Using your unit circle, if needed, locate 210 degrees, or approximately where 210 degrees would lie. And just tell me which quadrant, first, second, third, or fourth. Third quadrant. And so just give yourself a quick little sketch of about where 210 degrees would lie. Okay, I'm in the third quadrant, so that's what I'm saying. I'm not going to be exact on that, as long as you're close, in the right quadrant. Then you're going to then represent the angle using a little arc. Starting at the x-axis, doesn't really matter where, you're going to denote that angle by drawing a little arc with an arrow pointing to that terminal side. We start with the initial, which is the x-axis. Then I'm going to rotate the arc over and end on the terminal side. And then I'll write that as 210 degrees. And it says what quadrant? This is the third quadrant, 210.
Does it always have to go like this way? Or
yes.
can it go?
Nope, it always is going this way if, counterclockwise, if it's positive. Okay? Everything we're going to get to for right now is going to be positive. Okay, so now draw an X and Y axis. What do we notice about 510? It's past 360. 360 is a full circle. And guys, we just got done watching the Olympics. Snowboarders, snowboarders. You know, they do, how many turns can a snowboarder do in the?
1080.
Yeah, a 1080. And so that's however many turns. So yes, you can have more than a single turn. Don't be frightened.
I'm frightened.
Are you frightened from the 510?
I'm frightened because you just told me not to be frightened.
Subtract it from 360. You're going to subtract it. Sometimes you might have to subtract it more than one time to get it so that it's below 360. You can either just subtract, or you may use your calculator, but this ends up to be 150 degrees. Now, can I fit 150 degrees on here? Absolutely. So locate 150 degrees on your unit circle, get an approximate idea of where it's at. But now when we go to represent, now I'm not representing 150, I'm representing 510. So if I just started at the initial side and just went whoop, that's 150. I have to go all the way around and then end at my 150. That represents my 510 degrees, that I did a full circle and then some. And that landed in the second quadrant. Isn't this a little bit nicer than what we just did? Bless you. 315. Can I find 315 on the unit circle? Absolutely. I draw, and that is less than 360, so I can just do my full arc, and I recognize that that is in the fourth quadrant. Okay. If you have $14.50, I'm going to subtract that from 360. I get 1090. Subtract from 360 again. I get 730. When do I stop? Subtract from 360 again. I get 370. Subtract from 360 again. And I end up with 10 degrees finally. So I have 1 rotation, 2, 3, 4 rotations. There's my 10 degrees. So I would go 1, 2, 3, 4, and my 10 degrees is how I would work that. Look at that pretty spiral I have going. Okay? And so if you are over 360, just know that you'll need to subtract until you get it so that it's below 360. Okay, down below. And then we're finished for the day, finally. We are going to convert from radians to degree measurement. How many of you in here have ever heard of a radian measure? A few? Do not be frightened. Again, do not be frightened. Not that this lesson at all is frightening in any way, shape, or form. We measure temperature outside in Fahrenheit or Celsius. We can buy a gallon of milk or 2 what of soda? Liters. So gallons and liters. Fahrenheit and Celsius. If I'm measuring an angle, I can measure it in degrees or I can measure it in radians. Okay? We celebrate Pi Day. Circles are used as pi r squared. All right? So in essence, you guys have been looking at radian measure but didn't even realize it. We know that we're looking at radian measure when we see pi involved. We know we're in degrees if we see a degree symbol. So that will mean that I'm in degrees. pi will mean I'm in radian measure, okay? So don't be intimidated by the pi. It just means we're in radian measure. And we're gonna learn about a conversion, super simple conversion. It's either gonna be pi over 180, because 180 degrees is a half circle. Pi is also a half circle. They're equivalent to one another. Or 180 over pi. It just depends. So let's just put this into practice. Let's look at this. Convert 110 degrees to radians. So I'm going to write down what's given. So 110 degrees, and I'm going to create a fraction, and I'm going to multiply it by the conversion factor. If I'm in degrees, and degrees is in the numerator, and I want to get rid of it, I'm going to put the degree measure in the denominator. Because if something is in the numerator that's also in the denominator, they cancel out. And so then I know pi has to be in the numerator. Okay, now don't start throwing rotten tomatoes at me. But when you're converting like this, I don't want you to use a calculator.
What about rotten oranges?
Okay, rotten oranges, actually rotten oranges don't smell as bad, I don't think, but that would be okay. And they'd be soft too, so yeah. Do you see that they both end in 0? So the zeros automatically cancel because I can divide them both by 10. Now look, what's left? I'm finished. Gosh golly, didn't even need a calculator. 11 pi over 18. All right, let's look at B. 220 degrees. Degrees is in the numerator. Degrees need to go in the denominator. So pi is in the numerator that I'm multiplying by.
Why is it 180?
Because 180 is half circle. These are equivalent to each other. It's Kim? So from here to here is 180 degrees, and in radians, it's the same thing as pi. That's why that conversion is there. My zeros cancel, so I'm left with 22 pi over 18. They're both even, so they both can be divided by 2. So this actually becomes 11 pi over 9. Done. Now I'm going to go from radian to degrees. I write down what I have. I've got pi over 9. Pi is in the numerator. Pi needs to go in the denominator. And 180 is on top. Pi's cancel. Now you can pull your calculator out if you want to. 180 divided by 9 is nothing more than 20 degrees. And then 28 pi over 3, convert that to degrees. Pi's in the numerator. Pi needs to go in the denominator. Therefore, 180 goes on top. Pi's cancel. And if you need to, I still would think you could do this in your head. Well, maybe not quite in your head, but you could do some cancellations on your own. But you are welcome to take 28 times 180 divided by 3. Or recognize that that becomes 60, and 28 times 60 is a very large number, 4 degrees, 1,680 degrees. And the reason why when you're going from degrees to radians, you can't use a calculator because pi needs to remain in your answer. Okay?